So picking up where we left off yesterday, first thing we need to do is to find each real zero and its multiplicity. How do we find our real zeros yesterday? What did we do? Set the factors equal to 0. So we got to take our 3x minus 2 and take x plus 6. And go ahead and solve both of those for x. So for the first one, you would add 2 and divide by 3, which gives you 2/3. For the second one, we would subtract 6, which would give us a -6. Now, both of these factors, you see these exponents, that means that's the multiplicity. So both have a multiplicity of 2. So I'm just going to abbreviate that as MULT. And then we'll talk about what that means in part B. So that would be the answer to part A. And I gave you these numbers. This represents the questions in the homework that have the same format. For part B is asking if it is going to touch or cross. So whenever your multiplicity is even, it's going to touch or bounce. And both of these have an even multiplicity. So at both x-intercepts, it's only going to touch down. So it touches at 2/3 and it also touches at -6. And I'll make a sketch here to help you visualize what that looks like. Part C is asking us to determine the number of turns, which is the degree minus 1. So to find your degree, we're going to add our multiplicities, which would be 2 plus 2. So this is a 4th degree. So the max turns that this graph can have is 3. Because you just go down 1. So I'm going to make a sketch here to kind of help me give me some more space, okay? I'm going to make a little sketch off to the side to help us visualize what that means. Okay, so -6, I'm going to say that point is here. And then the 2/3 is somewhere over here. So it's a 4th degree. So does that mean that arrows will be the same or opposite? Who says opposite? Who says the same? It's the same, yep. Do you think they're going to point up or point down? Up, because we start with a positive. So what that means is that the graph is going to come down, hit that point, and then bounce back up. Make a U-turn, hit that point, and then bounce back up. It never actually crosses through. And if you look at the number of turns that I made a turn here. There's a turn here. There's a turn here. There's 3 turns. That's what I mean by what's the maximum number of turns. The max number of U-turns you can have is 1 less than your degree. So now let's do our end behavior, part D. And because it's even, we can write one behavior statement. So the limit as x approaches plus and minus infinity of f of x is positive infinity. Any questions? Monday's class, we're going to graph the entire period. So just a FYI, the homework is a worksheet, but the entire class is graphing. So if you don't have graph paper, I think I have a little bit left that you're more than welcome to use, or you'll just have to sketch it on your notebook paper. All right, does anyone need more time to copy this down before I move it away? All right, so we're gonna do one more. I didn't think we would have time, but we do. And that's C. So go ahead, take a moment and copy down function C. We're gonna answer those questions one more time. So we have f of x equals negative x plus 5. Here, let me zoom in a little bit. Negative x plus 5 times x minus 3 squared. All right, so part A says find your zeros and the multiplicity. So we have two factors. So we have x plus 5. And I have x minus 3. Let's go ahead and solve both of those. For the first one, I would subtract the 5, which gives me negative 5. For the second one, I would add 3, which gives me a positive 3. So this factor has an exponent of 1. It's invisible, which means your multiplicity is 1 for negative 5. My second factor has a multiplicity of 2. So question B says, what is the graph going to do? So at the negative 5, because 1 is an odd number, it does go through the graph. But at positive 3, because that's even, it's just going to bounce or touch. And on Monday, we're going to actually graph these functions. So kind of goes together what we're going to do Monday and what we're doing today. So to find your degree, I'm going to add my multiplicities, which means I have 1 plus 2, so this is a third degree. And because it's a third degree, the max terms we can have is 2. So I'm going to make a sketch again. And sometimes making a sketch will help you with your end behavior. So I'm going to say that negative 5 is here. And positive 3 would be somewhere over here. Now, does this have a negative or a positive leading coefficient? Does everyone see how this one starts with a negative? So because we have a negative leading coefficient, the right side goes down. So I'm just going to, off that green, which is my right point, I'm going to put a down arrow. And because it's a third degree, it's going to do the opposite coming off of that negative 5. So for this one, am I going to go through the graph or am I going to touch it and make a U-turn? What's going to happen at the -5? Who says it goes through? I agree. So it's going to come through the graph, then it makes a U-turn, it comes back up towards the +3. What does it do? It bounces, it comes back down. You can kind of see that. It's a really, really rough sketch, but that kind of gives us an idea. All right, let's go ahead and do our end behavior. So this is odd, so we have to separate it. So left side, the limit as x approaches -infinity of f of x. And then the right side, the limit as x approaches +infinity of f of x. So on the left, the arrow is pointing upwards. So that means that my end behavior on the left is +infinity, but on the right side is doing the opposite, is going down. All right, so go ahead and glue down your cutout. We're just going to write equations for both of those graphs, and then we will take our skills check. So we're going to practice writing a polynomial function from looking at a graph. So we're going to write a polynomial function based off what the graph looks like. So if you're titling your notes, it would just be for these two. It's just construct a polynomial in factor form. So this is the easiest way to write our equation. So we don't have to multiply anything. Remember, factor form, we don't multiply it. Standard form, we do. All right, so take a moment. After you have it glued down, I'll wait, and then we can work through these two. Okay, how many times? Show me with your fingers. How many times or how many x-intercepts do I have? How many x-intercepts do you see? Show me with your fingers. All right, we all agree that it's 3. Yep. We have one here, here, and here. So that means I have 3 factors. So let's start our equation. F of x equals, and I have 3 factors. Now remember, when you go from the 0 to the factor, what happens to the sign? It flips. So at this purple dot, which is at -4, the factor will be x plus 4. At my red dot, which is -1, that gives me a factor of x plus 1. And at my green dot, which is +3, I have a factor of x minus 3. But for one of these, it doesn't cross through. It bounces. Which one does it bounce at? X plus 1. So that means that we have to make that factor squared. And only that factor. If you look at it, you see how that looks like a parabola? It's squared. Here is going through. That's linear. All right, so if it looks like a parabola at that point, we need to make that factor squared. Now, if I were to add it, what do you think my degree would be? Show me with your fingers. What's the degree? It's 4. Because both of these have an invisible 1, right? And 1 plus 2 plus 1 is 4. So this is a 4th degree, which is even, and that matches our graph. Now, we should know it's not a 3rd degree because the arrows are the same. So it has to be even. It has to be a 2, a 4, a 6, a 8. Okay? Now, lastly, what is my leading coefficient? Is it positive or negative? Who says it's positive? So it's optional. I usually put a plus sign there just to remember that I have to put something in the front. Now, what this point is for is so we could actually figure out the exact number, but we're really not concerned with that at this point. We just need to know, is it positive or negative? And you don't have to put that there. Like, that's optional. You don't have to put anything. But if it's negative, you do need to. Yes, Luke?
I know where to put the next one.
The one, if it goes through it, it's 1. If it bounces, it's 2. All right, let's look at our second graph. Show me with your fingers, how many do we have? It's 4. So we have one here. We do have one here. And we have one there. And we have one here. So that means I need 4 factors. So let's go ahead and make our 4. Now this time the x-axis is counting by 1/2. So that red dot represents -3. So that would give me a factor of x plus 3. The purple dot represents -1. So that gives me a factor of x plus 1. The black dot is at 0. 0 does not have a sign, so that x is just all by itself. And then the positive 2 would have a factor of -2. Now, the way this is written right now, this is a 4th degree function, and we know it's not a 4th degree because arrows are opposite. So one of those needs to change to a square. So which one is going to square? Which one does it bounce? So when I'm looking through here, let me zoom in. Do you see how it goes through? Does everybody see how that goes through? It does go through here too. That goes through. But it's not going through here. That's not going through. So the x is squared. It is going through here. So now when you add it up, what would be your degree? What's 1 plus 1 plus 2 plus 1? 5. Is 5 odd? So that matches what we have. It's a 5th degree. Now, is my leading coefficient positive or negative? Positive. So this is a 5th degree, and it has a positive leading coefficient. Now, if it had a negative leading coefficient, I would put a negative in the front. But this one does not, so we are done.